Hi, everyone. In this presentation, I'm going to be talking to you about IT fundamentals, and we're going to cover some of the main components, objects, and ideas that we're going to be covering in this course. And the topics are the IT landscape, computers, operating systems, programs, and algorithms. And if you may note here that we're talking about computers, this is the hardware, and the operating systems and the programs are the software. And some of you probably noted this duality when I mentioned these items here. So let's go over the IT landscape. This is an image that I put together to emphasize the relationship between humans, their social life, and the information technologies that mediate our lives nowadays and also enable many of the activities that we conduct. As you can see here, we have people renting out books in the library. This information gets recorded in computers. The information of online event registration forms, your credit card being swiped in a cash register at a supermarket, people walking on the streets where cameras are filming what's going on the streets, retail stores of all kinds of items on the internet, our emails. All of this stuff is being operated on via information technologies. The data are being stored in server centers. They call these server centers or data centers, where computers are piled up in stacks like this, and there are usually multiple computers in each of these stacks. And they keep the information and provide the information, and they also run the programs as well that need to process the information, to process the data. And I'm using these terms, data and information, interchangeably. We'll kind of review differences in these terms soon in more detail. And here are some of the programs used in the server side, the computers that actually need to power the activities that we do today. All of these activities, of course, are related to social issues or related to professions that we have. Here we have an image of people in the street protesting to keep the internet free, for an open internet, or what they call net neutrality. Our social media are hosted on computers like this one. The messages that we send to friends and to the public at large, programs that we use, Word programs, to create the documents we need for our professional, educational, and social lives, are also sometimes connected to the internet, sometimes not connected to the internet, but they run on computers for people to use at their home, for people to use in their work. Also, computers are also used in more detailed or complex environments where critical information such as the infrastructure of gas pipes or light or weapons or missions to the moon are conducted. Much of this information is organized in databases of with a very structured format, a very formalized way to restore different kinds of information, such as the image here suggests. And all of this powered by digital technologies are based on this binary system of computation, which we will explore farther here in this course. So on computers, I wanted to just bring up the idea here that computers come in many forms. There are many manifestations of what we call a computer. They are the so-called desktops you may be aware of. Desktops, here's a Macintosh kind of desktop. Windows-based kinds of desktop usually, and previously Macintosh as well, have come with something called a tower, and you may have had one of these. And there's a disk drive, and there's a fan in there as well, and there's a power button, and maybe other kinds of, we used to have a floppy disk or diskette drive. Nowadays, we don't really use that anymore, but maybe CD-ROMs and so on. These are more stationary. They sit at a desk. You're probably familiar with some of these. They're the laptops. Laptops are kind of like desktops, but more portable. Nowadays, we also see things we call tablets. Usually they have a touch screen, but they are very similar to the desktop and laptops and the things that they can achieve. We have mobile devices. Sometimes we call these phones, just plain phones. These are probably more like computers with a phone rather than a phone with a computer. So these are really just handheld little mini computers, mobile computers, such as the iPhone or Samsung and so on. The large databases or computers that power large organizations that have a lot of data, a lot of programs running, we also call these computers. And as you can see, they look different than the other computers. A lot of the operations are very similar, actually, because they have operating systems like similar to the ones that we use, like Macintosh or Windows, running in these machines, so they can run the specific programs and applications that they need to run. A video game console, we can call these computers. They're specialized computers, but they are computer nonetheless. They have little microchips like the ones here. I don't know which one is the microchip. Actually, maybe this is actually the main microchip, but I need to double check. So video game consoles like a PlayStation or Xbox, these are essentially computers. Here we have a picture of a Raspberry Pi. You may be familiar with the Raspberry Pi. These are very small computers. This is the size of the palm of a hand, and this is a whole computer with output and input jacks for other input and output devices like keyboards and screens, but you have a whole computer here and you can fit in the palm of your hand. And also things nowadays that we call smart appliances. So your refrigerator may actually be a computer or have a computer in it that performs all sorts of functions, such as refill the ice basket or mediate the temperature in a certain way and turn on or turn up when it's necessary. Other devices, cars, microwaves, ovens may also have little computer chips in them and may thus operate like a computer. That was the hardware part of information technologies that we're going to be studying here. We also need to recognize the first or major layer of the software, which are the operating systems, and for short, we'll call this OS. And here we have images of the graphic user interface, or sometimes nowadays just interface, graphic user interface, GUI, GUI, of different operating systems. Windows here, the newer Windows version, the older Windows looks a little bit different, but they're all kind of coming to look very similar to each other. Here we have Macintosh operating system, and we see programs lined up in some kind of bar on the bottom or on the side. And each of these icons are specific different programs. Here we have Chrome OS, and it also looks very similar. It's just a window, and you can put pictures on the background. And usually we have a list of the applications or programs that are available. Here on the left bottom corner, we have Ubuntu, which is a kind of Linux operating system. And these are Windows, Mac, and Ubuntu are some of the major operating systems for desktop and laptop and server devices, whereas Chrome OS, Android, and others are for more mobile devices. Operating systems are actually very complex software programs. There are a lot of settings and a lot of computer code that needs to exist to create that layer, that software layer, which is a kind of malleable layer onto the microchip onto the hardware. And this is what, you probably have heard of Bill Gates. He was famous for helping develop Windows. He probably became the most famous out of everyone, but of course, I don't know the story, to be honest, but I'm sure it was a joint effort and he didn't really do everything by himself. And we have the Macintosh, and you have Ubuntu Linux. Linux is a more of an open source project, so it's the combination of various people coming together to develop the operating system. And one of the basic characteristics of the operating system that is more visible at the level that you will probably encounter, and that I think is good to mention here, is the directory structure or file structure. Because in a simple way, what the operating system does is create two things: folders and files. So let's not confuse these two here, because those are the only two different things that really exist. Folders are the containers for where to put stuff, and files is the stuff. Sometimes we'll call a folder by a different name. So if it's a major folder, like in the Windows-based machines, we usually have a C folder, but we call this a C drive. A drive is like a big folder where a bunch of stuff resides. So you see a C drive. Well, C drive is a C folder. There might be a D drive, and the D drive may be for the disk, the folder or the area where the disk information may be, like a CD-ROM. And the folders can go within folders, and the files can go in the folders, right? You put the stuff in the folders. Another name for folder is directory. Another name for file is document, but sometimes people call folders documents, and then everything gets mixed up. So let's just remember the difference between the two, whatever word you might be using. The documents themselves can be very complex documents, like programs, like a whole entire program or application. And they may look also deceivingly simple, just like a file that you double click. But once you double click, a bunch of computer code, which we'll talk more about in this course, gets executed, gets implemented, and runs the functions that you're able to see. The windows pop up, the boxes that need to be shown are shown, and the input areas that need to be shown are shown as well, and so on. And there are different types of documents, different types of files. Some are complex programs, some are just simple text documents, maybe just with a note, for example, with a single phone number or the single list of people's names, and so on. These are the files, and the operating system establishes this directory structure of documents and files. So programs are the more specialized software of a computer. So the main major software is the operating system, and then everything in the computer runs on the operating system. And the programs are the, let's say, specific applications, right? Specific meaning they are specialized applications. That is, they have a limited set of functions. Another name for programs is applications or apps, or sometimes just software, or sometimes software programs, and so on. But these are the basic names. Here is that interface of that Chrome operating system with just a picture on the background to make it look nice for the human eye. And then we have floating icons here, and each of these icons is a specific program, specific application. And Chrome is a program to access the web. So we call this the web browser, but it doesn't do everything. It maybe can play movies, maybe can read a PDF file, but it cannot do everything. It cannot store your music files, and or it cannot take pictures and things like that. But sometimes you can always add specific functions that may be present in other programs into one major big program. But usually they're fairly specialized, right? So the calendar serves as a calendar, the Scratchpad serves as a Scratchpad, the Google Maps serves as the Google Maps, Google search serves as a Google search. YouTube serves as YouTube. We know it's not a place for you to create Word documents, but it's a place for you to view videos and so on. Pop quiz. How many programs are shown on the image below? I'll let you pause here for you to think about it, and then I'm going to give the answer. So here I wanted to emphasize that when we're dealing with programs on computers, we may get confused which application is running and what is really going on. Now, at a certain sense, we're really not going to know what's the details of what's going on in the background while the computer is processing the data, and we really don't have time to unless that's our job. But we should understand some of the basic levels of how programs work. And here the answer to this quiz is 2. We have 2 programs. One program is the web browser itself, which is also another deceptively simple application, deceptively simple program in operating systems, which usually nowadays only has a kind of search bar or address, rather search bar, it functions as a search bar or an address bar right here. We have a back and forward button and a refresh button, some little icons here, and then some triple dot here. There's a picture here. And this is it. This is the end, or yeah, kind of this is the end, the extent of the program and its options. And then here we have a scroll. And then if you click here, the triple dot, you get more settings, more functions. But this is the one program, and this is a browser, a web browser. And you're probably familiar with it. That's one program. And then the other program is DuckDuckGo. DuckDuckGo is a web search engine, and it's a web page. So you go to it by going to the web browser, and you access. By using the web browser, we can access other applications, other programs, including the DuckDuckGo program. Now, we don't call these programs like the Google program, Amazon program, NewYorkTimes.com program. We call them sites, website. DuckDuckGo.com is a website. Google.com is a website, but they are actually programs. They are very complex, in fact, applications with various functions and algorithms that we will talk more about in this course as well. And DuckDuckGo is a more privacy-oriented search engine. It functions very well. I think sometimes it's even better than Google, has less advertisement than Google, so I highly recommend. And so the answer to the quiz is 2. We got 2 applications going on. So just to finalize here, when you're going through DuckDuckGo and you write something here that you're looking for, maybe you want to buy them new, like pink pants, you write pink pants. You are dealing with a browser, because the browser has to process and serves as the window for your access to DuckDuckGo. But DuckDuckGo is the one really processing this information, taking your query, we call this a query, and putting it into its own database, its own systems, and searching for the pages to give you the results. Okay, so let's talk now about algorithms. Algorithms are components of programs that carry out a function, or that is one or more function. And I bring this word up here because it's an important word nowadays, and I want to make sure we all understand what algorithms are. And they're really not that special. They're really just in terms of the basic definition. So if we understand the notion of programs, then algorithms are the specific functions of the programs. Sometimes an algorithm, sometimes a program is known by its algorithm. For example, the Google web search engine is known for its PageRank algorithm. But the program itself, the whole Google infrastructure to search web pages, is much more just that one algorithm. But for example, if you're using a Word software to create a text document, And you might have noticed when it catches a misspelled word and it highlights here with red, for example, that's because within this program, there is an algorithm, there's a function that identifies whether a word is misspelled or not by matching all the words, by matching this word and all the words to a dictionary and see if it's there or not. And if it's not there, and it highlights it and says, hey, I don't think this is in the dictionary, so you might want to double check. There are just an infinite amount of functions that can be created and that can be created into an algorithm. Another definition for algorithm are just instructions with limited cycle to find end results. So identifying customers that have visited the store once a week on average, identifying which neighborhood has most crimes and when. So when you're capturing this kind of data, you can process that data. You can do all kinds of things with the data and computer programs by creating functions and algorithms. Algorithms are important because they're also technical models of how to evaluate reality and make decisions. And that's why algorithms are really an important kind of component of life in the age of computers and the internet. So as I was mentioning before, every web search engine application has their own algorithm to determine what the best pages are given a specific query. So I went to DuckDuckGo's web search engine, and then I typed in Martin Luther King because, well, I wanted to know about Martin Luther King and what comes up first. How does this program decide that this page here, Nobel Prize .org, should go on top and then followed by National Geographic? What comes up on the top or on the first page is very important, right? Because most people just want it right there. They don't want to have to search for many useless other web pages. So how does it do that? Yeah, well, we actually talk about later in the course, but it is a set of processes to evaluate what is correct, what is right, what is good for the situation. When somebody types a name of someone famous like this, what kind of information should we retrieve? So this is why these are models of how to evaluate reality and make decisions. So for example, it says the best neighborhoods to invest in. So maybe you capture, there will be an algorithm to obtain data about crimes in an area. But crime is not the only thing that implicate whether somebody should invest or live somewhere, right? Jobs, quality of the food, or schools, and so on, may be characteristics that people are important for people. So bringing all that together and weighing which one is more, which one is less, that's an algorithm. It's a model of how to evaluate reality and make certain decisions. That's it for this set of presentations, and I'll see you next time.